All right, let's talk about one of the most underappreciated gadgets in your entire house. Seriously, we often take our appliances for granted, but some of them are hiding some seriously impressive science. Today, we're going to pull back the door and uncover the astonishing science of your dishwasher. You know the drill, right? You load it up, press a button, and you walk away. A couple hours later, it's like magic. Clean dishes. But what is actually going on inside that sealed box? I'll tell you. It's a chaotic ballet of high-pressure water, extreme heat, and some pretty sophisticated chemistry. So, what's the secret? Let's find out.
So our journey starts with Act 1, a masterpiece of engineering that happens without a single motor. I'm talking about those spinning spray arms, the ones that do all the heavy lifting. The secret to how they move isn't electricity, it's just pure, elegant physics.
That's right, there's no motor spinning those arms. Nope. Instead, they work because of a fundamental law of the universe, something Sir Isaac Newton figured out way back in 1687. For every action, there is an equal and opposite reaction. This one simple principle is what powers the whole show.
And get this, it works on the exact same principle as a rocket engine. A rocket forces hot gas down to push itself up. In your dishwasher, the pump forces water out of these little angled jets. As the water shoots out one way, that force pushes the arm in the opposite direction, making it spin. You've basically got a mini rocket launch happening in your kitchen every night.
So that's the big picture physics. But now, we gotta zoom in, way in, to the microscopic battlefield that's happening right on your plates. This is where chemistry takes over, deploying a team of tiny, targeted superheroes to just completely obliterate those food stains.
See, modern dishwasher detergents are way more than just soap. They're these sophisticated formulas packed with something called enzymes, and each one is a specialist. You've got protease enzymes, which target protein stains from meat and eggs. Then you have amylase enzymes, and they go after starches like pasta and rice. And lipase enzymes? They are designed specifically to break down greasy oils and fats. It is a full-on tactical assault on grime.
But why does this even matter? Well, because these enzymes are incredibly efficient. They give you amazing stain removal, but at lower water temperatures. And that not only saves a ton of energy, but it's also way gentler on your delicate glassware and dishes. It's all about working smarter, not just hotter.
Okay, so we've got physics and chemistry working together. But here's a question. Your dishwasher saves water by recycling it during the wash. So if it's just sloshing dirty water around, how in the world does it know when the dishes are actually clean? Well, it turns out it has a brain, or at least a very clever set of eyes.
Let me introduce you to the unsung hero of the modern dishwasher, the turbidity sensor. Now, turbidity is just a fancy word for cloudiness. This little optical sensor is basically the machine's eyes. It shines a beam of light through the wash water to measure just how much food and grime is floating around in there.
Here's how it works. As food washes off your plates, the water gets all cloudy and murky. The turbidity sensor shines its little light, but all those dirt particles get in the way and block the beam. And that sends a signal to the control board that basically says, hey, we're still dirty in here, keep washing. So as the cycle keeps going, the water gets cleaner and cleaner. Eventually, that sensor's light beam can pass right through the water with almost no problem. That's the signal the dishwasher's been waiting for. It tells the brain, the dishes are clean, mission accomplished. Then the main wash cycle ends and it moves on to the final rinse.
And this sensor is the answer to that very common question. Why do new dishwashers take so long to run? It's because they're designed to be incredibly efficient with water. Instead of just running on a timer, they run until that turbidity sensor confirms the job is actually done. So those super long cycles are a sign of precision, not a flaw.
Okay, the dishes are clean, the water has drained, but we're not done yet. Now we get to the final phase, getting everything dry. And in the world of dishwashers, there are two competing philosophies on how to best get this done.
On one side, you've got traditional heat dry. This is just brute force. An electric heating element fires up and bakes the water off, kind of like a little oven. It's fast, it's effective. On the other side is condensation dry. This method's a bit more subtle. It uses a final, super hot rinse to heat up your dishes. Then, as the steamy air inside cools, the moisture is naturally drawn to the cooler stainless steel walls, where it condenses into water and drains away. It uses way less energy, but it can take a little longer.
And now for the question that has plagued dishwasher owners for generations. You open the door to a machine full of sparkling, dry dishes, except for one thing. Why are the plastic containers always still covered in water?
Well, the answer isn't your dishwasher's fault. It's just simple science. Ceramic plates and glass cups, they're dense, they absorb a lot of heat, and they stay hot for a long time. That retained heat is what helps the water evaporate right off their surface. Plastic, on the other hand, has very little density. It cools off almost instantly, leaving the water droplets with no energy to evaporate and nowhere to go. So, the next time you load your dishes, remember what's really going on in there. It's not just a simple appliance, it's a finely tuned machine using the laws of physics, advanced chemistry, and smart sensor technology. It's an invisible marvel of engineering working silently in your kitchen. Which kind of leaves you with one final thought. If your dishwasher is this complex, what other secrets are your everyday appliances hiding?